Hello and welcome everyone. Welcome to the e-lecture series. I am Dr. Jignesh Shah, working as a professor in the Department of Quality Assurance at LJ Institute of Pharmacy. Dear students, in the last class we have started with UV visible spectroscopy, where we have gone through the basics of radiation, how the radiations are being formed, what are the different terms which are involved with radiation, such as wave number, frequency, wavelength, how energy is associated with all these terms, what is the correlation of wavelength, wave number and frequency with the energy of radiations, and also we have gone with the important points or characteristics with respect to radiations. In today's class we will continue with the same topic, that is UV visible spectroscopy. We will move forward towards our next content, that is the EMR spectrum. Which are the different types of radiations that are involved with EMR spectrum? What are the different types of spectroscopy and how the mechanism of spectroscopy it takes place, or what is the theory behind spectroscopy? So dear students, these are the contents of today's class, that is EMR spectrum, study of spectroscopy as well as its types and theory. Now, moving towards the first topic, that is EMR spectrum. Now, what do you mean by EMR spectrum? Basically, EMR spectrum, it is the arrangement of all different types of electromagnetic radiation, and this is a particular way of arrangement. This way of arrangement is done according to increasing wavelength of the radiation, or we can say that it is with respect to decreasing frequency of the radiation. In the earlier class, we have gone with the relationship between wavelength and frequency. Wavelength and frequency are inversely proportional to each other. So the arrangement of radiation with respect to increase in wavelength or decrease in frequency is basically termed as EMR spectrum. Now this EMR spectrum, it is associated with different radiations who are having different energy, and all these radiations, as they are having different energy, they are related with a specific techniques, or they are mainly used for some different purposes. For analytical purposes, these radiations are being used. Now, in case of electromagnetic radiation, these radiations, as they have a specific energy associated with that, they interact with molecules very specifically. Every molecule is different because of different kind of functional groups or different kind of bonds which are present in that particular molecule. That's why for every molecule to be analyzed, there is a different way of electromagnetic radiation to be used, or there is a different mechanism associated with its analysis. That's why we can say that electromagnetic radiations, they interact very specifically with the molecules with whom we need to go for the analysis. Now, different kind of mechanisms which are involved with the analysis by EMR, they may be absorption, they may be transmission, it may be scattering or reflection, it may be diffraction. So these are different mechanisms which are involved with the analysis of a particular molecule. In case of absorption, the absorption of the radiation will take place, whereas in case of transmission, we are going to determine the amount of light which has been transmitted from the sample, whereas in case of scattering, we will determine that at what angle the scattering of the radiations has been taking place. By the process of reflection, we can also determine some specific molecules, or we can determine the properties of the oil or purity of the oil. In case of diffraction, we are going to study the diffraction patterns, and on the basis of that, we can analyze the structure of the crystals. These are various different mechanisms, and every mechanism is associated with different type of analysis. Now, if you see the diagram which has been shown here, this is an electromagnetic spectrum. If you see towards your extreme left hand side, it is the gamma rays, and if you see towards your extreme right hand side, they are the long radio waves. So if you move from gamma radiation towards the long radio waves, you can see that the wavelength of the radiation increases, but the frequency of the radiation, it decreases. Now from the diagram which has been shown, we can say that gamma rays are followed by X-rays, which are followed by UV, then it is followed by visible light, which is followed by IR radiation. Next is microwaves, then it will be radio waves, and the last one will be long radio waves. So gamma radiations, they are associated with much higher energy, and long radio waves, they are associated with lowest amount of energy. So this is the information about electromagnetic spectrum, where you can find out that what is the frequency a particular radiation is associated with it, and on the basis of that you can also predict that what amount of energy is associated with that particular type of radiation. Now wavelength and frequency, as all of you know, that they are inversely proportional to each other. So wavelength, it is also inversely proportional to the energy of the radiation which it is associated with. Now, electromagnetic radiations, as per the electromagnetic spectrum, we can say that they are categorized on the basis of its wavelength. That is, they are categorized on the basis of its energy. There are different types of electromagnetic radiations which we have gone through. Among them, radio waves, microwaves, infrared waves, visible light, UV radiations, X-rays, and gamma rays. It composes the entire electromagnetic spectrum. Now, among all these radiations, it is the visible light which is the visible light which we can easily see through our naked eyes from the entire electromagnetic spectrum. Remaining all other radiations, it cannot be visible through our naked eyes. Now, starting with the types of radiation, as we have gone with the names of all the radiations which are composing the electromagnetic spectrum, we'll go with some important properties of these kind of radiations. The first one is radio waves. Radio waves are associated with maximum wavelength, that is, they have maximum wavelength and they have minimum energy. Now, as the name implies, that radio, it is basically used for the transmission, that is for communication purposes. Radio waves are used for the radio broadcasting, TV broadcasting, and even in case of cell phones, we use the radio waves. Radio waves, they have lowest amount of energy associated with them. Radio waves, they are also used in remote sensing technology also. They are also used in case of radar systems where radio energy is released and bounce back energy, it is being captured. Now, especially radio waves are also used in predicting radio energy. And this radio energy can easily pass through the atmosphere, and hence we can predict the weather patterns also. So weather forecasting or weather patterns, it can be also analyzed by using such kind of radio waves. Moving towards the another type of radiation which comes after the radio waves, that is microwaves. Comparatively, microwaves, they are associated with higher amount of energy as compared to radio waves, but they have lower wavelength. So it can be also used for the broadcasting information through space. Energy of microwaves, as all of you know, that it is mainly used in case of household purpose, that is for the cooking food. It is mainly used in chemical synthesis nowadays. Microwave synthesis or green synthesis, it has been commonly used by most of the chemical laboratories. So microwave synthesis, it is gaining more importance nowadays. They are also used in remote sensing, in which microwaves have been released. They are also good in transmitting information, and they are sometimes also used in case of Doppler radars. So they can be also used to predict weather, that is, weather forecasting can be done. Now, microwaves, they fall in between IR radiation and between the radio waves. Moving towards the next type of radiation, that is IR radiation. Infrared radiation, it is most commonly used radiation in case of analytical field, where by using IR radiation we can predict that what kind of functional group may be present in a molecule. So functional group determination can be done by IR spectroscopic technique. Higher radiations, it can be released in the form of heat energy or it can be released in the form of thermal energy, and they are associated with higher energy as compared to microwaves. They are also commonly used in remote sensing, as these IR sensors, they will have an ability to collect the thermal energy. They are most commonly used for functional group analysis also, and also they are used in determining the type of isomerism in case of isomers. So a specific type of isomer, it can be identified by the help of IR spectroscopy. So two different isomers, they can be differentiated from each other by this technique. Progress of any chemical reaction, it can be also analyzed by IR spectroscopy. So sequential IR analysis, it may help you to determine the progress of any chemical synthesis which is taking place in a particular lab. Next, going through the visible radiation, visible light, it is the only part of radiation as we know that we can see only this visible spectrum of light. Now, this includes different kind of colors, that is Vibgyor, violet, blue, green, orange, red. These are basically different types of colors which can be seen by our naked eyes. In visible spectroscopy, light is allowed to pass through a particular matter which is either absorbed or it is transmitted or it is reflected on the basis of its wavelength and on the basis of the type of the sample which is present. So this visible radiation is very important in analyzing most of the colored compounds. So colored compounds can be analyzed by visible spectroscopy. Even some kind of derivatization techniques also needs visible spectroscopy as an important analytical tool that can be used in regular laboratory studies. Moving towards other radiations, that is, if you go through UV radiations, X-ray and gamma rays, these are all radiations which are related to the events that are occurring in space. Now, as all of you know that UV radiation is considered as one of the most harmful radiation as it causes mutation. Genetic mutations is being done by UV radiations, and this is one of the most important factor which leads to cancer. As a result, UV radiations are very harmful for the humans. But UV radiations, they are also important with respect to quantitative analysis of the compounds. Most of the quantitative analysis of the compounds, UV spectroscopy, it is used. In most of the monographs, 70% of the monographs in pharmacopoeia, we can see that UV spectroscopy, it forms a fundamental basis of the analysis of the compound. X-ray, they are also used for analyzing powder crystals. We can determine the crystalline nature of the compound. Also, we can determine polymorphism by using X-ray diffraction techniques. So polymorphism, different types of crystals, they can be analyzed by using X-ray. Gamma radiations, they are mainly used in case of chemotherapy, but the specific intensity of the radiation, it should be controlled while it is being used for radiation chemotherapy, uh, for radiation techniques. The shortest waves, they are the gamma rays, and they are associated with the highest amount of energy among the entire EMR spectrum. Now, if you go with spectroscopic studies, it has been classified into two types. One is absorption spectroscopy and the another one is emission spectroscopy. Now, basically, absorption spectroscopy, it mainly deals with the absorption of the radiation. Now, basically, any molecule, if it is having a chromophore and if it is having an oxochrome inside its molecular structure, in that case, it has an ability to absorb the radiation. Whereas in case of emission spectroscopy, we are going to determine that how much amount of the radiation has been emitted from the compound. So this emission of the radiation is because of the excited electrons which are coming back from metastable state to the ground state. And this emission of the radiation, it has been determined, and on the basis of that we try to analyze a particular compound. We will go with a detailed study about absorption spectroscopy and emission spectroscopy when we cover these particular classes as an individual topic. In the next class, we'll go with the theory of spectroscopy. I hope that you might have uh, cleared your basic concepts about spectroscopy. Hope that you might like the video. Kindly do not forget to follow our YouTube channel, that is Pharma Ignite. Thank you very much.